Good morning, Year 10. In this video, I'm going to be going through the solutions for the 5 questions from Week 4, Term 3 for Friday. Question 1, we need to graph a cubic on a plane, which is y equals x cubed plus 2, and I need to use this table of values. So the first thing I'm going to do is, using my calculator, I'm going to write bracket cubed plus 2, and I'm going to substitute in those different values. So starting with minus 2, I'm going to have negative 2 cubed plus 2, which is negative 6. Do it again with negative 1, I get 1. Do it again with 0, I get 2. Do it with 1, I get 3. And when I do it with 2, I get 10. All right, now I'm going to put that on a plane. So I'm just going to quickly draw one now. Okay, and because you can see we're going to go from negative 6 to 10 on the plane, when I'm going up and down, every line for my grid I'm going to make a space of 2, and every one across I'm just going to make a space of 1. So even though I've got a different scale, as long as it's good for the x-axis and good for the y-axis, it's fine. So that's 1, 2, 3. I'll do the same for the negatives. Now if you did something different, that's okay. It will look a little bit skinnier than mine, or maybe a bit taller. Like, things change a little bit when the scale changes, but the general shape should look similar. So that's going to be 2, 4, 6, 8, and 10. And then this is negative 2, negative 4, negative 6, negative 8. Okay, and now I'm going to plot those points. I'll do it with black. So when I have negative 2, I go down to negative 6. So I'll do a dot there. Negative 1, I get 1. So I'll do a dot there. 0 and 2, I have a dot there. 1 and 3, there'll be a dot there, and 2 and 10, I'll have a dot there. Now just remember it's a cubic, so it's curved, not a straight line. So I'll do a generally curved shape, making sure I go through those points, and that is my cubic. For question 2, we need to solve x squared plus 5x plus 6 is equal to 0. Now Nate made a note to remember to factorize. So remember, when we're factorizing, we're going to do the product sum. So the product, what multiplies to get 6, and the sum, what adds to get 5. So I'll go through the list, but I can already see that if I did 2 and 3, so I did 2 times 3, I'll get 6, and 2 plus 3, I'll get 5. So I can rewrite x squared plus 5x plus 6 equals 0 as x plus 2 times x plus 3 equals 0. So that's the factorizing part done. Now to solve, it's actually quite easy. What value of x will work to make this equal to 0? Because then it'll be 0 times something, which would equal 0. So for this, it's going to be negative 2. And for this one, it's going to be negative 3, which ends up being the opposites of the signs in there. So negative 2 and x equals negative 3. Next, we need to find theta for this triangle. So we've been given 2 points, 35 degrees and 85 degrees. We don't know this one, and we need to find theta. Now, what we know about a triangle is that they have an angle sum of 180. Okay, so that means that I'm going to call this x. We're going to have 35 plus 85 plus x, and that will equal 180. So the way I'm going to do it, I'm going to just I'm going to add 35 and 85 together, which gives me 120. So 180 degrees is equal to 120 degrees plus x. So that means that x must be 60. Now there's a couple ways to do that. But one way is just to look and kind of figure it out that way, or we can do 180 and we take away the 120 and we're left with 60 degrees. Okay, so I'm going to write this, that's 60 degrees. Now to find theta, well, this is a straight line, and a straight line when we're looking with angles is always 180. So just draw a line here. 60 degrees plus theta is equal to 180. So that means theta is going to be 120 for the same reasons that we found before. So that's the answer. But now what this is actually called, it's got a name. It's the exterior sum of opposite angles. So here's the exterior angle. If we add these two together, we actually get theta. And it's because this adds up to be 180 and this adds up to be 180. So of course, if we add these two together and this, that's going to be 180. If we add this and this, that's 180. But in this case, this and these two, when you add them together, are equal. So long story short, you can do it this long way, but if you notice, you've got two angles and then the exterior angle of the opposite, then you can just add them together. So that's probably a bit too in depth, but if you just do this triangle way, that's fine. That's absolutely fine. So for question 4, we need to solve log base 2x is equal to 32. Now I don't know what to do there, so I need to change the form. So I'm going to do the BAP form. So it's already in BAP, so BAP. So that means I've got a base of 2 with a power of 32, and that is equal to x. So I just type into my calculator, what's 2 to the power of 32? And that will give me my answer. Oh, it's a big long number. It is 429,496,7296. Wow, that's massive. Yeah, that's the answer. Cool. Now, question 5. We need to find the volume of a sphere with radius 5 centimeters correct to 3 significant figures. Now, with this, we need to remember what is the volume of a sphere. Well, it's 4 on 3 pi r cubed. Now, you can look that up. When you're in year 11 and 12, regardless of which maths you pick, you get given that formula, so don't worry. But it's good to try and remember them if you can, because it speeds up processes. So that means the volume is 4 on 3 times pi times the radius, which was 5 centimeters cubed. So I'm going to type that into the calculator. I'll do 4 on 3 times pi times 5 cubed. Gives me 523.59877 and so on. Now to 3 significant figures, that's not 3 decimal places, that's the first 3 non-zero digits. So in this case, that is 523. But then we have to look at this so we can round. So it's going to be 524, and that's going to be centimeters cubed. And I'll write in brackets 3 significant figures, and I just write it like that because I'm lazy, to be honest, and I'll just do the minimum that I need to get through the answer. So there we go. That's the answers for the 5 questions for today. Next, we'll be looking at hyperbolas and